Hi everyone. Nice to see you all today. I hope you're having an okay little break. I think I'm out of focus slightly. I hope you're all having a nice little break. And when I say break, I mean, that period where you're both exhausted from term and stressed about exams. Um, I put an hour and a half in the calendar this morning for this little revision lecture. Now, we've got 11 people here currently. The hour and a half is just indicative. There's no plans or anything. It was just like that seemed like a logical amount of time. I don't know if we'd use more than that. I don't know if we'd use less than that. But we'll kind of just go until we run out of things to talk about. Um, so you can shoot questions my way about the exam as well. The only thing I really wanted to probably actively talk about today is just a little bit of a comment on um, the exam questions. Um, and the reason I say that is because, as you know, this exam structure is a new structure, which we cobbled together via a series of older exam papers and a couple of modifications and stuff. Um, the only kind of difference, the main difference being the short answer questions. Um, and since we've last spoken, approximately 10 days ago, I think, what's happened is the final exam has been written. It's finished. It's ready to go. We're getting it checked and we're getting tutors doing it and all this kind of stuff, but it's largely ready to go. And um, naturally, as part of that process, as we wrote half a new exam, kind of, we found some very old questions. We tweaked them, we changed them, and we rewrote, bunches of it. There were some subtle differences that I think we noticed in terms of the sample exam and the final exam. So the main thing, honestly, is like just looking at the sample exam. The sample exam has 4 programming questions, right? 4 programming questions. Yep. So some things I can tell you about the final exam are that the final exam has 5 programming questions. Now, they are not worth more marks, right? It's just 5 questions. Um, I would say that if I had to guess, the programming questions in the final exam might be slightly more work than what you see here. Um, but that's about it. It's going to be approximately the same. Like it's not going to be twice as hard or anything like that. It's all within a factor. Again, I say that, and some people will find the questions easier, and some people will find them harder. And so, like, don't take that personally, kind of thing. But it's like the programming stuff's the programming stuff. It's pretty much the same. We've got the same kinds of questions like this. It's like, oh, here's 2 ADTs, and here's a test file, and here's the file you're editing, and here's a make file, and here's some tests. Um, one difference about the final exam is that in the practice exam, I think I only gave you 1 test, 1 input-output per question. In the final exam, I've given you 2. So you should have 2 inputs and outputs per question. Just a little bit more help. I was just feeling like that would be appropriate. But besides that, again, the programming part's the programming part. Um, the programming questions, just thinking through them now again, uh, they're not that hard in the sense that when I say they're not that hard, what I mean is that they're not like excruciatingly difficult. And in particular, they're not going to punish you for not understanding a really complex piece of theory really deeply. In terms of, you know, we are testing what I would consider to be relatively like mid tier programming abilities. It's nothing crazy. Like, you need to solve this really complex algorithm. I don't think we put any time complexity restraints on any constraints on any of the questions. Um, so what I'd say to everyone in terms of advice for the programming part of the exam is again, what's going to hurt you most um, is a a lack of comfortableness with programming. that's what I think will be the biggest divide for people. Now, obviously you need to study, you need to revise, you need to do all of that. But the thing is, like, the exam questions, and I mean this honestly, if you did both assignments and you've done the labs and you got all of that, then everything in the programming part of the exam should be really digestible. Like, you should be able to look at it and be like, I understand what it's asking of me, and I have a vague idea of what to do. People who know exactly what to do because they feel comfortable with these kinds of problems, that they will probably bash through it. Most of you will find at least one or two questions you'll have to sit there and think about it, and that's where you'll probably lose a lot of time. But fundamentally, like, my encouragement to everyone again when it comes to studying for the final exam is just get comfortable programming. Get comfortable, like, just like if you haven't written C in a week or two, it's like go redo some labs, go write some questions, because you again in this exam you don't want to spend time asking yourself, is this a pointer, or like, how do I make a helper function, or anything like that, right? You go play around with some ADTs. Go and play with the graph ADT. Go and play with the tree ADT. Go and play with a linked list ADT. Like, go and do these things, because getting comfortable with that will make your life a lot easier. Because you want to spend time thinking about how to solve problems, not thinking about how to write the solutions, right? Yeah, that's my only advice. But programming is pretty easy. Like, everything I just said there is relatively, like, it's kind of what we said it would be. I'm just giving you some more tips and advice. The one thing I did want to comment on, though, is around the short answer questions. So the short answer questions are 30 marks and all of that. The main difference with the final exam is that we don't have this kind of like question 5 A, B, C, D style. It's more like we actually have, I think, 10. I think it's 10. I think it's about 10. It's about 10 short answer questions, and it's just one question per thing. The reason I have to point this out is because, and I just hope you can be understanding here, is that to write a whole short answer exam is kind of hard and time consuming, and it's really hard to then go and write an entire sample short answer exam with a whole separate set of questions in the same time window with the timing we have with trimesters and stuff. So naturally, like, I don't have this whole pool of short answer questions for you. I want to talk about a few of them today. But my point is that the short answer questions here, it gives you a sense of the difficulty, it gives you a sense of the size. The only difference is that with the final exam, you should expect more questions that ask you to just explain yourself a little bit. So if you notice that these short answers here, it's all kind of like, give me a number, give me a number, give me a number, give me a number, right? Like, give me this, give me that. It's just a lot of like, give me that. And in the final exam, what I'd say is that you're more likely to see questions that are not just like how many multiplications are performed, but we're going to ask you a lot of like explain yourself. So it'll be a lot of like question answer, right? Like, what's an example? I wrote some examples down last night that I want to kind of talk to you about. I'm not trying to spook anyone. It's short answer. It's 30 marks. You write some responses. It's just the shape of the answers are a little bit different. They're also kind of similar to lab questions and tute questions. Like, if we go back to tute questions, like, I don't know, tute 3. I haven't looked at tutes for this, but yeah, like, here you go. Like, because again, I've run a lot of exams and I've taught a lot of courses now, and it's like, what always happens is students like, they're like, I need to know, the sample exam needs to be modified to contain the exact question I'll get. And it's like, well, I mean, not really, because like, this is a perfect exam question. I'd put this on an exam. I mean, I wouldn't, because it's in a tute and it's an open book exam. But if it was a closed book exam, I'd put this on. I'd literally give you this question. At the beginning and the end of the header files, we typically place this stuff. Explain the purpose and how it achieves that purpose. That's a short answer question for an exam. 2 marks, right? Something really simple, a few lines, where we want you to show us you know the answer, and show us you know why that's the answer. That's kind of a common thing in the exam. And the main reason we do that, honestly, is because it's how we can really test your knowledge. because anyone can answer questions, and you can also share answers really easily, right? Like you can just write the same answer. But if you have to explain it in your own words, it's really hard for people to copy. And we get to test your knowledge properly, because like it doesn't matter if you know what the answer is. If you can't like explain it, then that's no good. So I'll give you some examples I've written down as well. And these are just a few random ones. Is if I was to say to you, for instance, here's one. What is a challenge faced when calculating a Hamiltonian path? Or, in what scenarios would you prefer bubble sort over selection sort? Justify your response. Or, I would share with you a piece of recursive code. Say, like, let's say I give you a merge sort code. Justify the use of recursion here as opposed to iterative solution. 2 marks, right? Very small questions. I don't like. So we opted away from asking like longer questions. I think if you remember in the final exam sheet, it said something around the lines of short and extended answer questions. We opted away from extended answer questions because the reality is there's a whole bunch of international students here who English is their second language, and if you put too much pressure on them to write open-ended, I think you basically then start to punish some people for just not being as like fluent with the language, you know, because it's like easy like English speaking is a requirement of studying at UNSW, and it's easy to kind of expect that everyone should be able to write a couple sentences, and it works. But in the past, I found when you ask more open-ended stuff, you start to really be examining language abilities a little more than relevant to the course. So we didn't end up going with any kind of like 5 or 6 mark, like, you know, here's a scenario, really explain it. You know, it's very short and sharp, like these kinds of questions. A lot of just like, you know, in what scenario, like, you know, so it's like an example for like, in what scenario would you prefer bubble sort over selection sort? I mean, I don't really know if there's any scenario you'd prefer selection sort over bubble sort. I just wrote these down while I was in bed last night, just thinking about this lecture today. 'Cause I've never used a selection sort for anything, but let's assume I'm not missing anything obvious. Is bubble sort adaptive? See, I don't keep these things off the top of my head. Bubble sort should be adaptive. Yeah. So, you know, it's like, well, since bubble sort is both adaptive and ON best case, with ON squared worst case, bubble sort would always be preferred over selection sort, which is ON squared always, or something like that. Now, I'm not saying, like, you know, I didn't ask this question in the exam because I don't think the answer's maybe that clear cut. That's why I'm giving it to you now. But it's like that's an example right there. So if like there's a question, it's like, what challenges faced when calculating a Hamiltonian path? You could say here that, you know, the time complexity for calculating it, what would you say it is not polynomial time, and therefore for large graphs could not be reasonably computed, or something like that, right? Like, again, I didn't ask any question about that NP complete stuff because I don't think we touched on it a lot. I think it made sense to a lot of people, but I don't think we touched on it enough throughout the course to like hammer that home. And then the last question here with merge sort, justify the use of recursion here as opposed to an iterative solution. You know, you'd probably Google it. You probably Google and you just say, you Google an iterative merge sort, and you'd be like, you know, while iterative merge sort may avoid any recursive stack call blowouts, like whatever you call it, you know, like, you remember we talked about recursion, how you can make too many recursive calls and you run out of memory because they're all stacking on top of each other. A recursive solution is clearer to read and simpler to understand. And yeah, Chewy said ON for time complexity is ON factorial for Hamiltonian parts, right? So the point I'm trying to get at here is that I'm just trying to kind of reiterate that uh, the final exam questions will be like little short bursts of questions, right? These are quite concise answers, by the way. Typically, as students, you'll ramble a bit because you're really worried that if you don't ramble a bit, you'll like not get enough marks. So, I would expect for a kind of question like this, most students would write twice as much as this. I did actually add in the questions. Uh, how would you put it? Like I wrote in the questions like the rough word count if you just because I know people freak out if I don't give it to them. So I was like, I basically wrote in some questions like this one. I was like, your answer should be between 20 to 80 words, which I know is a broad range, but it's just like, I know some people really look at these things and they think like, is my answer too short? Is my answer too long? And this isn't a requirement either. Like, I'm not even going to share this with your tutors or anything that mark it. I'm just like, it's just so you don't totally freak out with things. But yeah, so that's kind of the thing. So your final exam is approximately 9 or 10 of these questions like this. And most of them require just a very short a sentence or two explaining things. Yeah, I think that's all I wanted to share about it. People have asked me again, do you have sample solutions for the final exam, for the sample exam? I don't. I'm really sorry. I'm chasing up someone who has them. They're not replying to me. We're not resourced to write a whole swath of potential answers in 2 days. I'm sorry about that. Like I wish that wasn't the case, but it's just kind of true. The only thing I would add is that a couple things on the sample exam. So it's a sample exam. So if anyone wants to share your answers on the forum, please feel free to. Like that's totally okay. Like if anyone's just done it and they just want to share their answers and ask someone else to see if they got the same things and then discuss it, that's fine. Like that'd be great. Even that, it's probably an easy way for everyone to get in sync. The second thing again is that I don't want to leave you all with this because this happens every time. It's like I don't want to leave you with this impression that because like you don't know every single thing on the sample exam that you're kind of screwed because you have these amazing tutes and labs to go through as well, which are like, 80 plus percent, 80 to 90% of what you should be studying is in the tutes and labs and assignments. So like the sample exam is not there to prepare you for the exam and with all the content and so that you can understand everything. It's there to give you again a sense of the size and the scale and the difficulty. And to summarize again, because people have asked, I would guess that the average student will come out of the final exam and go, oh, that was slightly harder than the sample exam, but not like wild or anything like that. I mean, you're gonna be like it's hard because it's stressful, right? Like everyone's like, exams are stressful, but we've had a look at it and we're getting tutors to look at it and we think it's great. So, and I think the other thing, just to reiterate to everyone once again, is that if for some reason we're getting 3 tutors to look at this, a range of different tutors, we've already got another 2 staff looking at it. We've already cut some things out. It's like if for some reason when everyone sits the exam, and this is just to de-stress people, if it turns out that it's actually like harder than we thought, right? In terms of like students struggle with it more than we expected, you don't need to worry because we would just scale the marks up a little bit. That's it. Like we probably expect an average mark in this exam of, I don't know, some number. Let's just call it 60. 65 as a raw mark or some mark like that. It's like if the marks are lower than that, we just move them up. We just move them up proportionally with some thought, and that's how we balance things out. So like, don't really stress because it's yeah. The don't worry if you kind of are like, oh, it's a little bit harder than I thought. I'd worry if you think it's a little bit harder than you thought and everyone else is like, that was a lot easier than I thought, right? But if you think it's a little bit harder than you expected and everyone else thinks it's a little bit harder than they expected, it's like, don't even worry. Like, it'll all sort itself out. So yeah, only worry if you found it hard and everyone else found it easy. Chewy says, the marking for assignment 2 will come out on the 23rd of August. Are we able to get the auto marks for assignment 2 before the exam so we can have a rough idea? Yeah, we're trying to sort that out. Try and get the auto marks out probably today or tomorrow. Yep. So I think that'll be good. Yeah. Yeah, actually, Chewy, that's funny. So Chewy's just made a comment in the chat which says, justify breadth first search over depth first search. You get the shortest path with breadth first search. Is this an okay response for short answer? So that was the other one. I knew I forgot another question I thought about this morning. Thought about this one in the bathroom this morning. Was like, we might give you something such as a graph. Like, imagine I gave you like a map of Sydney, and I said, I want to use either BFS or DFS to find a short, not necessarily the shortest path from Kensington to Penrith. Which should I use? Justify your response. Now again, this is a kind of standard exam short answer question. Is like the key parts here. You would probably use depth first search because it's better at finding deep nodes quickly, and depth first search because it's not optimal, but that doesn't matter. Optimal being that depth first search is not guaranteed to find you the shortest path. So yeah, again, that's another example of a kind of question. A lot of the justify responses are there to weed out people from looking at, like, who we don't want you just to be able to look at the lecture slides and write the answer down, right? Like you probably write the answer down, but the justify part or the explain part, we can usually tell people who just copy and paste things from slides or who don't actually answer it properly. Like, this is a great example of it. It's like this one is, I think that's a great kind of exam question. I think a silver lining on the short answers, I think I just want to clarify too, is that with these kinds of short answers, the ones we had in the sample exam, which are a little bit more like calculaty and a little less typey, like word typey, I actually think that some of the typey short answer questions are actually easier because we don't actually, like, how would you put it? Like, if you've studied, you'll know the answers instantly, right? Like, you'll look at it like, this is an easy question. This is a pretty easy question. You probably double check it. That's like, these are all questions that if you're familiar with the content, you just have to write the answer, as opposed to, like, print things out in pre-order and like calculate it and potentially get it wrong. So yeah, or like this stuff, like, just, yeah, less calculating, because like we kind of figured that you're gonna do so much thinking in the programming parts, like we don't want to tire you out by like solving even more problems up here. There are two about 1/5 of the short answers are questions about calculate the time complexity of this code. That's the other hint I'll drop. So we give you a piece of C code or a piece of pseudocode, and we ask you to calculate the best or worst or average case time complexity of that code. That's another thing that happens. Okay, I think I'm I think I'm out of things to share. Are there any questions? Do people have questions about topics or, again, the exam? I understand that it's harder in this course to revise everything because, we kind of talk through a lot, and you know, we can't go and like code an entire thing from scratch realistically. But yeah, any questions about the course content? Questions about tutes or labs you want clarified? Questions about quizzes you want clarified? Any of that? Uh, so I'll just go backwards. Rebecca says, just to double clarify, the non-programming section will be worth 30%. Yes. Yes. I think that's the case here too, right? 6, 7, 13, 17, 24. Yeah, 30%. 30% of the final exam will be the non-programming section. You won't write any code. It'll just be short answer responses. Chewy says, I'm still a little bit iffy with average case, time complexity, and week 9's content. Ah, okay. That's a good point. You might need to be more specific about week 9's content, but let me talk about average case time complexity. In the majority of this course, thankfully, so with average case time complexity, a lot of the time there's no real easy way to, like, you can either figure it out one or two ways. Which is there's the simple way, you know, which is just, you just divide it by 2. So like quite often if you have something like bubble sort's a good example. It's like if you have a bubble sort, you know that the best case is ON and the worst case is ON squared. Yep. Because best case it does 1 sweep and no swaps and it's done. Worst case is it has to do n sweeps and swap n times. Typically your average case is also your worst case. And the reason for that is because typically your average case is just your worst case divided by 2, which, as you know, coefficients get removed, so it just ends up being your worst case. Now that's like if you're shit out of luck in terms of your confidence, that's the answer typically. The more comfortable way to think about it is to actually write out the different scenarios. So, for instance, bubble sort is kind of an easy one to calculate because it's a linear thing. So it's like you think, okay, so just trying to think. So I'm just going to think of a better answer. So the short answer here is to understand average case is really not that different from worst case and stuff because you're essentially just summing up different cases. And like bubble sort as a good example, when we say bubble sort's n squared, and even though I just described it as n squared, in reality, it's actually more complicated than that, right? Because if you bubble sort numbers in the worst possible order, just seeing if I could find something small online, like if you bubble sort numbers in say this order of like 9, 8, 9, 8, 7, 6, 5, 4, right? The next one you're going to get is when you swap 4 all the way down, so you get 4, 9, 8, 7, 6, 5. And then you'll end up moving 5 all the way down, 4, 5, 9, 8, 7, 6. But the thing is, if you look at this one, and then, you know, if we kept doing this, obviously it'd just be 4, 5, 6, 9, 8, 7, and then 4, 5, 6, 7, 9, 8, and then 4, 5, 6, 7, 8, 9, right? So we did this 6 times. So there's 6 numbers. We sweeped it 6 times, right? And each of these times here, how many swaps did we do? Well, I mean, I guess technically, well, I think we then had to sweep it 1 last time. Anyway, you get the point, right? This one here, how many swaps did we do? Well, we had to move 4, 1, 2, 3, 4, 5. So we had to move 4, 5, there was 5 swaps. This one we had to move 6, 1, 2, 3, 4. So we had to move 5 4 times. So the point is that as you go through this more, you get fewer and fewer swaps. Like this. So this is if you want to figure it out from kind of first principles. So we know that we had to sweep 6 times, but we also know that each time we swept, we kind of did less swaps. So what you end up with here is you actually end up with kind of n plus n minus 1 plus n minus 2 all the way down to 1. Or 0, I guess, technically. Or, yeah. Yeah. Doesn't really matter. And the thing is, so when you're actually looking at the worst case here, you can just kind of look at this and be like, all right, what is that? And then you end up with, what is a very common thing with kind of time complexity is generating an arithmetic sum or using an arithmetic sum formula, which is here, if I remember high school. An equals a plus n minus 1d. You should all remember that because you're younger than me, I hope, and therefore you remember it better than me. As like, you have like the sum is equal to a, which is the starting value, which I think is, which way would we go? Oh, have I done this wrong again? Nth term. I did this last time. My lord, I can't get this one right, can I? So the sum is here. It's like n on 2 times by 2a plus n minus 1d, like that, right? And it's like, okay, well, what's n in this case? N is n. So it's like n on 2a. Let's say the starting element is 0. I don't think it really matters here. Let's say it's 0 plus n minus 1, and then the d, which is the difference between them all, is 1. So you just end up with that. And now we end up with n on 2 times by n minus 1, which gives us, let's just say it's a half times by n squared minus n. That's just pulling the half out and expanding the brackets. And then we end up getting rid of that front coefficient. We get n squared minus n, and then we remove the lower order terms and we get n squared. But in reality, we didn't do n steps, did we? We did exactly this many steps. We did exactly a half of n squared minus n steps. So in reality, it's quicker than n squared, but for time complexity, it's like not. And so it's like with average case and stuff, you just have to ask yourself again, like, what is the average case? Now, like, what is the mid ground here? Now, for a bubble sort, it's hard to visualize what a what an average sorted list is here. But the thing is that for bubble sort, if it was an average sorted list or something somewhat random, you're still going to end up with roughly the same formula. It's just the values of n will actually be smaller in reality because you had to do less sweeps. You're still probably going to have to do, 4 sweeps or whatever, but it's not going to, you're going to do n on 2 sweeps and n on 2 swaps. So it's like if you want to think about the average case, you might say, okay, the average case is just n on 2 squared minus n on 2. Because you do half the sweeps and half the swaps. Or something like that. You end up with the same value in the end. So that's how you can kind of think through these things. But honestly, in like an exam setting, you're either kind of going to know it, or you're going to Google it, or you're going to guess it. Like, you're not going to derive this stuff in an exam for the kind of marks these things are worth. So from an exam standpoint, I definitely wouldn't worry. Because again, you're either going to know it, you're going to look it up, or you're going to Google it. That's it. Yeah, so I mean that was kind of an answer to Chewy's question about I just normally drop the coefficient usually for yeah, you just give the worst case. That's pretty much spot on. The same is true for like binary search. So like binary search, best case is O1 because it's the first element. Worst case is log 2n, which is log n, because you have to like do the maximum number of jumps. And then average case is what? Well, it's a half log n, because you only need to do half the number of jumps. But you could stack all these up too, right? Like if you've got just trying to think, Yeah, like I don't even know how I think about it. It's just if you have 10 cells, the average case of searching is going to be 5 cells. If you have 8 jumps to do in a binary search, the average case of jumps is going to be half of that. So a lot of the average case ends up being the worst case. Okay, Anthony says the circular array lab question is a good example when it was pretty rare to make more memory. I'm not sure what that's in relation. Oh, okay, sure. Right, so we're talking back around the circular queue or circular whatever, same thing. Lab where it's like you had to make more memory, and there was that weird kind of understanding of memory where like um you know you had to malloc every 8 or some number. You had to kind of every time it filled up, you doubled its size and malloced. And mallocing had a cost. Typically, this isn't really like a whole concept to understand. This really comes back to the whole idea of again amortization, which if you Google amortization, you get here you go. I believe it is a financial term. The action or process of gradually writing off the initial cost of an asset. Now, that's quite interesting in finance speak, but it's somewhat translatable to computer science in the sense that it's about looking at the load of something. It's about looking at the load of something over a long period of time. So you don't really look at it and you say to yourself, okay, well, let's say that every time my array doubles is a cost. Okay, well, what's that cost if the array ends up being a trillion? And it's like, the answer is nothing, because it's like a limit to infinity or whatever. It's like, if you have a cost, like if you have a recurring cost that gets smaller, like non-linearly downwards, basically like the linkless queue example, then it just ends up disappearing, because remember that big O notation is looking at really large numbers. So when you say, okay, well, what's the cost of, if you have let's say that you have you have an insert cost. So inserting is O1 because you're just adding to the end of the array. Okay, well, it's O1, like if you have an array of 8 items, the first element is O1. The second element, let me make this 4 items. The second insert is O1. The third insert is O1. The fourth insert is O n plus O1. The fourth element's O1. Sorry, I meant the fifth. The fifth element, now it has to resize, which means it's On plus O1. So what happens now is that to insert this, it's actually On for the fifth element. But the thing is, since again you resize it, as you go to the sixth element, and the seventh, and the eighth, right? Because it's gone from size 4 to size 8 now, you can insert another 4, and it's only on the 9th one you have to double it. I think I've done this right. Anyway, you get the point, but the point is that as this gets bigger and as we go like 10th, now you can go like all the way up to 15th or whatever. It's not resized till the 16th one. So it actually resizes just again like progressively less and less. And as you get even bigger, it does the same thing. So now it won't do it till the 32nd one. But the point is that as you get to massive numbers like billions and trillions, that you're going to have like O1, that's going to happen like a billion times. And then you're going to resize it, which will be On, which will happen once. So now suddenly it's 1 out of a billion times. As opposed to right at the start here where it's like 1 in 4. So the point is that, for 1 in 4 of these cases, you're going to have to resize the array. Whereas when the numbers get really big, it's like 1 in a billion. And like, what do you know from maths? Like, if you have a fraction that's like asymptotic or whatever, then it goes, 1 in 4, 1 in 16, 1 in a billion, 1 in a trillion. And that number approaches 0 and is effectively 0. And that's kind of what amortizing is. You're just getting rid of that cost over a lot, like an extended period, because it does get amortized out at such a large scale. Anthony says, I just think of that as the classic average case not equal to worst case. I think that's fair. I mean, Like that is an example. I mean, I could tell you with confidence that there's nothing on the exam that's going to make you think that hard. That's for sure. I mean, about like average case time complexity. Yeah. So like, at the very least, I don't want anyone getting stressed about it. Um, but the thing is, like, average case time complexity, it's like one of those things you rarely come across a time in your life where you need to derive it. You kind of just you get asked it, and then you come up with an answer, and then you Google it, and then you got it wrong, and you're like, why did I get it wrong? And then you figure it out, and you're like, oh, won't forget that again. Like, a lot of people in this course won't forget about this kind of thing. But the main thing to stress here is that the reason this particular case is different, so that's like insert best case for a circular queue, or an extendable queue, I should say. Circular, whatever. Insert average case equals O1. And insert worst case equals ON, I think. Yeah. The reason that this one's different is because you have a cost that occurs less frequently as it gets bigger. That's the thing here, right? So the cost happens less often as it gets bigger. If that isn't the case, then you're not really dealing with very complex things. Like, for instance, bubble sort doesn't have some cost thing that suddenly becomes cheaper the more numbers you have. Either does most other kinds of sorts and a bunch of other stuff. So, yeah. Week 9's content. I'll give you a quick crash course on just what I think matters here. Yeah, we can talk about business stuff and coding stuff if we kind of run out of questions before 12. I'm happy to. Obviously, I wouldn't want to take up time for the course. We'll see how we go. So, heaps. So what you probably want to know with heaps is you probably want to be comfortable with how they're inserted and deleted and stuff conceptually, right? So like, you just kind of want to know how this works. Now, in reality, I've kind of dropped a bit of a hint that in this exam, it's very unlikely that we're going to ask you to implement a core data structure. It's unlikely that we're going to ask you to implement a linked list or a graph or a binary tree or a heap. We're more likely to give you something and let you work with it. Now, we might ask you to implement it or part of it, but if we do, it's kind of quite small. So you don't need to like stress about knowing how to like build all of these data structures from scratch. It's not going to be a massive part of the exam at all. So heaps, again, the priority is really to understand how it works. Because as an example, we could ask you a short answer question that says, here's a heap, and then here's a heap after an insert. Has this insert gone correctly? Justify your answer. And if you don't understand how heaps work, you're not going to be able to answer that. So that's just like something to think about. So understanding just how that works is useful. The inserting, the fix up, the fix down. The complexities are also useful. Heap complexities are pretty simple. Is it log n? Oh yeah, sorry. Heap complexities: log n, insert, log n, delete. Understanding a priority queue is just a structure that uses a heap. Understanding that heap sort is just a sort that just adds to a heap and removes from a heap. Like, this is that's the main things from this. You just you just need to understand all of that stuff. I don't think anyone needs to get too caught up trying to implement a heap, but also like most of the core data structures in this course we give you the code for anyway. So it's like we're not going to ask you to implement a fix down because you just copy it from the slides. So you don't lose your mind about like the code here per se. Because as long as you understand the concepts, that's kind of really useful. Linda said, should we know about set ADTs? Yeah, I mean set ADTs are just arrays that don't insert elements twice, or they're just linked lists that, or they're binary trees. I mean, a binary tree is a set ADT, really. Well, a binary tree could be an implementation of a set ADT. But the short answer is yes, you should probably know about set ADTs, but I don't think they're like a whole topic or anything that are separate. Um, in terms of hashing, um, I think most of the content here is something you should be comfortable with. I think the only things about hashing I'd say that you don't need to stress about, you don't need to spend much time thinking. I mean, the implementation again, like we're not going to ask you to implement an insert because we've given it to you before. But like, so don't worry about the code thing again. But the two things I'd say are that we're not going to ask you to write a hash function. We didn't cover that enough for that to be interesting. Like you don't need to look at these and think, what if I have to do this? We're not going to ask you to write a hash function. And then also when it comes to hash collisions, which you do need to know, we're not going to ask you to have to like express yourself really, like you're not going to have to understand this table here or anything like that. So we will expect you to understand the costs involved, like what's the relative time, like, cost of, or like, how does, like, we just want you to understand it a little bit high level. Basically, if you remember the lecture on this, we talked about it as like, this one's better than this one, and this one's better than this one, and this one's worse than this one. But we didn't go into like, analyzing hits and misses or anything super, super crazy. So, yeah, you need to understand this enough, but you don't need to like, spend hours looking at this formula, for instance. Don't worry about that, for instance. And then tries. Tries are a relatively straightforward topic anyway. It's just a tree. It's just a tree with a different structure. You should be comfortable with like how tries work. Again, they're just trees, so there's not a lot of new concepts for you. It's just different struct. You should be comfortable knowing how to insert and remove from a try. A try is something that we might ask you to. Here's a try, and we want you to write an insert function, or write a get word, check if word exists in their function, or something like that. We could give you a try structure with a create and a delete and ask you to implement an insert or something along those lines. So I think that's totally fair. Obviously, you could get asked about the complexity of a try somewhere in the short answer. If you saw a question like this, like the BST-like tries or the compressed tries, it would be in the hardest question in the exam. So that's kind of, and this is true for some other topics as well, like converting a binary tree to a 2-3-4 tree. That would be pretty hard. But like those kinds of like more intense data structure manipulation questions, if they're on the exam, I feel like I'm playing games with you if I'm not, just having to speak broadly. I've told you to study things that are on the exam, and I've told you to study things that aren't on the exam, to be clear. Like, this isn't me just sending you in the wrong direction with all these things, and it's not me telling you everything either. But yeah, questions like this with tries, or if you look at this and you're studying and you're like, oh, it sounds really confusing, just take comfort that if it's on the exam, it's going to be like the last 10% of separating students kind of question. So that's true for a few topics. Like as I said, maybe some harder parts of AVL trees, like converting a binary tree to an AVL tree would be interesting. Cool. Any other questions? What other questions? Oh no. Could you go over the tree partitioning, tree rotations for double rotations? Sure. I hope that's what I think it is arriving today. So I was just checking my phone and I had a parcel being delivered. I was ordering some computer equipment for my employees, and some of them live in Melbourne, and I ordered them a laptop, like not with my money, but I was just reading my phone and I thought I bought a new bicycle and I thought my bicycle was arriving today, and I was just reading through the tracking thing and it was like it was like, oh, your delivery's coming today. It's currently in Victoria. And I was like, oh, that's weird. I wonder if it's still coming up to Sydney. And then I like read further down and it was like, no, it started in Sydney and then it went to Victoria. And I was like, oh my God, my bicycle got sent to my employee's house, but I hope I'm wrong and it's actually just their laptop. But sorry, that was why I blanked out there for like 20 seconds while I was waiting for answers. So Linda said, can we go over tree partitioning, tree rotations for double rotations? Sure, are you talking about AVL trees specifically then? Is that what you mean by... Anyway, let me just maybe start with balancing BSTs. So, in terms of tree rotations as a concept, I don't know if I have personally much more to add on this other than, you know, that, how would you put it? This is like the rotation process is just a process you have to familiarize yourself with and kind of get used to and look through some examples. And there'll be a lot of visual guides online that'll explain this, just as I have in lectures as well. So tree rotation as a concept is just the act of picking a node, and you pick a node and you rotate it, and if you take a node like 24 here and rotate it right, as I've said in the past, for me it's kind of like you take the nodes on the left, and because you're rotating 24 right, they just end up kind of twisting up that way, which is why you get a structure like this. And that's just kind of tree rotations. Now, a topic in the lectures was tree partitioning, which is an interesting topic. And the idea with tree partitioning is that if you go through your tree and you give everything a... Is it in order? If you give everything an... Yeah, sorry, it's written on the slide. If you give everything an in-order index, tree partitioning is the process where you're always wanting to do rotations on the tree such that the middle index is at the root. So in this tree, or close to the middle index. So in this tree here, I have 11 items, and that means I've got 6 items on the left-hand side and I've got 4 on the right-hand side. So tree partitioning is saying that I really want 5 here to be at the root. So I'm not sure if we carried that example. I don't know. This was just like a starting example showing the indexes. So tree partitioning, you find the indexes, you make the middle index the root. The reason for that is because the theory is that tree partitioning generally helps you find the helps you generally balance the tree. Because remember, like fully balancing a tree, like if you just get a tree that's unbalanced and you want to perfectly rebalance it, that can be a really expensive operation. So the only ways that are generally like endorsed for rebalancing are kind of rebalance as you go. So partitioning is an example of something that you might do infrequently, or every 10 inserts or something you might check what the index of this element is and potentially like rotate this one up. So in this case here, let's say I've inserted 10 elements into this tree, and every 10th element I'm going to partition. I find the index 5 here, and then I just, I rotate H left, which pulls the J up. I rotate E left, which pulls the J up. I rotate M right, which pulls the J up, and then I'd end up with my J at the root. And an example here again is like, to partition this one, you've got 1, 2, 3, 4, 5, 6 elements, so you kind of want either 2 or 3 at the root. Doesn't really matter. So, if you want to pull 29 to the root, you'd have to rotate 30 right. You'd then rotate 14 left, and then you'd rotate 10 left. And that's how you'd end up with that structure on the right. So you'd have to do 1, 2, 3 rotations to get it up there. We gave you some pseudocode for it. Time complexity similar to insert at root. Yeah, so the time complexity of a partition is the time complexity of like whatever it takes to move a worst case element from a leaf to the root, which is the height of the tree, so it's OH. That's typical for a lot of tree stuff, right? So the complexity here would be OH, or O log n. But this one assumes that it's, well, O log n is fine, but the thing is, if the tree's not relatively balanced, O log n gives you the wrong number, because OH could be theoretically n, or it could be log n, depending on how balanced the tree is. Like, it's somewhere between those two. So that's why, you know, the complexity of partitioning is typically ON. The only thing I'm not too sure on, and therefore I could pretty confidently tell you wouldn't be on the exam, is that we don't have anything on the exam about calculating the indexes and then partitioning. Because I don't think we talked about calculating indexes in the course. Like, obviously you could calculate them by doing a search of the whole tree and like pinning indexes on things. That'd be possible. Like, you could do like, you know, a index reset could be ON, because you go through n elements and then you put indexes on them and then you find the right one. But there's nothing on the exam about calculating the indexes for a partition or anything like that. How much does that answer your question or questions, Linda? Cool. So Sydney says, how should we manage our time in the exam? Oh, I mean, it's hard to say because everyone does things differently. I would go straight to programming, because programming can do your head in. You know, if you just start with the short answer, then the problem is you'll kind of finish that in, you know, let's say 30 minutes, maybe. Short answers are meant to be pretty easy marks. You'll finish it in 30 minutes, and then you'll try and spend 2.5 hours straight programming. Like, I would look at the questions. Like, my approach would be, I would look at the questions. Anything that you look at and you just think, I have no idea, like F, that looks hard, I would just leave it. Just totally ignore it. And then I would start on the programming questions that I'd do the easiest programming question, just to give you some confidence and settle you in. And then I'd probably try and do a harder one, because you'll get stuck on it. And then once you're stuck, the second you're like, I'm not making progress, just stop it. Move on to another question or move on to short answer. But I don't know. I'd use short answers as a way to diffuse your mind around, like, not getting too caught up in just programming C and getting stuck in questions. I think another really important thing is, you know, you got to know when to stop. This is a really hard thing in programming exams, particularly auto-marked ones, is like, if you're halfway through a question and you're just not getting it, and like we told you about how the marking works, just stop. Just forget about it. Just move on. Like, you're not going to get it all. You need to go into an exam like this knowing that there's going to be 1 or 2 programming questions that the average student's just not going to finish. Like, when I say finish, I mean you're just not going to get it. You're just going to know it's not working fully. You know, it's giving you the wrong results, or it's doing something. It's like, if you go in knowing that, just don't waste time then trying to invest like 40 minutes into it. Like, never during my entire time as a student studying in the past did I ever find that spending a quarter of the exam on one question was worth it. Because a lot of the time, if you're struggling that hard with a question, you're probably going to get it wrong anyway a lot of the time, you know? Like, I don't know, maybe it's a thing from high school, because I feel like high school was a thing where you kind of get through 80% of the questions really easy, and then you just really hone in on that last 20%, and you get it over the line, and everyone was already getting 90s anyway, so it's like that last 10% was imperative to really just punch that little bit above. I just don't think the same really happens at uni very much, so just don't be a hero is my point. You can try. Like, if you know you're a hero, be a hero, but like, you know, it's don't if unless like, make sure you do the low hanging fruit. You get the easy and medium questions right. Yeah. Um, that's how I'd say. Yeah. So anyway, the point was don't start with the short answer because you use that to break up your brain. Um, you can look at it, sure, but like I just wouldn't. I don't know. Maybe it's just me, but I go crazy whenever I do anything for too long. I have this like vivid memory in high school of finishing all my exams except for physics, my last HSE exam, and it was the hardest exam to study for because I didn't realize up until that point that if I kind of got sick of maths, I'd go do some English, and if I got sick of English, I'd go do some science and so forth. And it was just like 3 days where all I could do was learn the same thing and or like do the same thing, and I went crazy. It was like it was like the easiest thing to do and the hardest for me to actually do. And I think that's true a lot these days still. So, um, yeah, don't do all the English stuff, so to speak, and then leave yourself with all the code stuff because you'll some of you will get sick of it. Um, I think if you really if you're a star programmer who struggles to write anything, then you could also do that the other way around. Is like start with the short answer, um, because it's hard, and then like to take a break, go do the programming. So I should really clarify myself and not say start with the short answer. It's like start with the stuff that you're less comfortable with so that you can break things up a bit. Um, yep, that's the answer to that. Any other questions? Chewy says, I used an AVL tree in assignment 1, but I found that binary search tree was usually faster. Is this just the luck with the initial root, or because the amount of words were not large enough to notice a big difference? Maybe both. Again, it's hard to say as someone who didn't spend hours on that assignment myself. Um, it's a great case study though because um, actually, I'm honestly I'm gonna take a copy paste of that, and I might put it in the lecture slides if I ever teach this again, because that's like a great kind of question. Um, to like to be like, a student asked this once. Yeah, so two things. It's anytime you're dealing with a data structure that is more advanced, it's usually going to cost more unless you really take advantage of it. So yes, the order of inserts is going to have a cost. It's a little bit like if you do a binary search that requires sorting of a list before you search it, it's like if you insert all the numbers just magically in sorted order, it's going to be more expensive. And an AVL tree is similar. Like if things got inserted in the correct order or a correct-ish order, or a not terrible order, then sometimes the cost of all the you know checking and stuff is more expensive than just the binary search taking longer. The other thing as well, as you said, the amount of words were not large enough to notice a big difference. That's also true again. I mean, that's why when we did the quicksort lecture, we actually talked about, how for small quicksorts you just use insertion sort. Because sometimes the cost of these bigger things it doesn't help at small scale. Um, you know, like if you have a sibling, which one of you can run to the kitchen faster? It doesn't matter. The kitchen is just down the hallway. It's the same kind of thing. So, if you need a big run up and you need to it's just so that's you've pretty much nailed it on the head in terms of like it's either going to be a case of the scale we're dealing with was pretty small in the scheme of things, or it just happened that the tree wasn't the natural ordering of the tree through insertion was just relatively not terrible, and therefore binary search tree was slower, but the cost of balancing might have compensated or been about the same for it. Really hope that was not my bicycle. Oh no, it wasn't. It was the laptop. Good. Ah, I had to buy my employee a Mac. I've never bought a Mac before. My God, they're expensive. The big ones. The small ones aren't too expensive. But by golly, like a $4,000 laptop's kind of crazy. Any other exam related questions? I'll give you one more minute. If you have any other exam related questions, let's just post them now so we don't have to play this waiting game every 5 minutes. And you don't have to. I'm just asking, you know. I mean, Chewy says that's cool if my question was on the slides. I mean, that's good because, you know, I mean, a big part of this course is always like, you know, why? You know, and like, why? Like, does this even work? Does this even matter? I mean, to be honest with you, in the real world, most of the stuff doesn't often matter that much. Like, if you're working, most jobs is just get it done. And the hardware's pretty cheap. The main area that this stuff really helps with is closer to I mean, this is just my educated guess, but it's just like, um, Google is like kind of a classic example. Maybe Amazon too. Any of these massive scale companies care about this stuff a lot because, um, you know, like what's the cost of indexing an entire YouTube catalog based on a search? You know, like these things are absolutely insane in terms of the scale and the bandwidth and everything else. So, um, you know, a lot of time complexity stuff, it kind of matters a lot or it doesn't matter much. Um, and to be honest with you, often too, I mean, one of the better things about this course is that, in my experience, again, a lot of students don't go away from this course and then they go end up in the workplace and then they're asked to sort some numbers and they're like, which sort am I going to use? You know, I'm going to use like a merge sort or a quick sort. But rather, it's more like you have a problem where you wrote some code, but it takes half an hour to finish. And you have to ask yourself the question, why is it taking half an hour? How can I make it quicker? How can I make it 10 times quicker? And you look at for loops, and you look at while loops, and you look at this, and you think about this, and you kind of just get a general sense of like, oh wow, that's actually like, we're actually doing this a million times, and then for each of those million elements, we're actually doing a million operations on each of them. You know, and then you think, how can I, like that's the kind of experience you end up with more than like specifically dealing with sets of data structures or algorithms. Solutions for assignment one. I'll ask Kevin to share some thoughts about that again. He said he was going to post some stuff up on the forum. I'll get him to make a pinned post about that. Can talk a little about red-black trees because it was one of the top. Oh, top solutions. Oh, sorry. Right. I see those things are. I might leave that one for Kevin if that's okay. I'll just ask him to post some stuff on the forum about that. Um, yeah. Because we're running low on. I mean, I think it's. I think at this point, what I'll say is that because no one's really asking more questions about the exam, that anyone who's watching this recording, because again, some people watch this recording with like very little time to study, you know, and they want to really cherish all their time. What I'll say is that I'm not going to answer any more questions on the exam today. So if someone's watching this quite pragmatically, you can just stop it now. And I'm happy to answer any other non-exam related questions for the last 15 minutes about the course. Or, I mean, was it Anthony? You said you had some questions as well. So we'll do that just till 12. Yeah. Someone wrote something with 6 loops. I mean, you generally want to avoid 6 loops. That being said, again, it's like if you're dealing with, 50 numbers and you're looping 6 times, like what is 6 to the power, wait, what is 50 to the power of 6? Yeah, what is 50 to the power of 6? Let me Google it. It's it's only 78 seconds. Like it depends what you're doing, Like if you're writing something that is only ever going to have 50 items, then and it can take time, like it's not maybe it's a service or a calculation in the back end. It's like that's not bad. The thing is, like, we say n to the power of 6, right? For I had a friend in industry who said they had a for loop, 6 nested for loops. It's like you say n to the power of 6, but if you know that the number of elements is only 20 or something, it's essentially constant time. Like that's the kind of funny thing about this stuff too, is like if your inputs aren't scaling, then you're often just constant timing everything technically, and you don't need to think too much. Like then it's just how long does it take in seconds. You're not really thinking about designing it efficiently because you're like, like at work we have jobs that take 30 minutes to run, and they could be made more efficient, but they run at 3 a.m. And we don't, like, why do we need to make things run quicker at 3 a.m.? Like, we would rather spend time elsewhere, because in the real world, again, you have 1,000 problems and enough time to solve 100. Maybe again, if you're at some big tech companies with oodles of money where all they do is, make everything perfect, then sure, but, generally speaking, you got to make choices. Andre says, what made you pursue a comp sci degree? God. I don't know. Oh, I liked STEM very early on. I don't think there was much doubt about STEM probably since like I was 15 or 16. A lot of people I think are like that. I really liked mechanical engineering. I really considered doing like aviation stuff. And I think just towards the end of high school, I remembered that I'd done some programming while I was in high school, like earlier on. Not like a ton, just a little bit of web stuff, and I just really liked it. And I thought computing sounds fun. And then I thought, what'd be cool? It's to like program planes or program mechanical things. So I got interested in mechatronics. And I started off at uni doing mechatronics with comp sci, but I realized very quickly that mechatronics degrees aren't actually that electrical. And I didn't realize early on that I actually found electronics a lot more interesting than mechanics. In hindsight, I wish I did an elect comp sci degree, because I think I would have stuck with it. And I tried to change halfway through, but I was too tired. You know what it's like. The deeper you get into uni, the less you can just like put up with, just like if you're in 4th year, doing like another math 1131 is just like, it's like putting a crowbar through your skull. It's just like you're like, oh, I'm so over this. Did this already. Yeah, and I ended up dropping mechatronics because I still loved robotics. I just didn't like the mechanics. I just didn't enjoy thermodynamics and fluid dynamics. Like it was interesting, but like it was interesting to learn about, but you then have to do the maths, and you're sitting there trying to solve some random equations, and I was just like, I just don't really care about this. So I ended up just sticking with comp sci. But in a lot of ways, comp sci for me has always just been something that's more natural, and I've always wanted to do more than it. Like like who doesn't want to work for SpaceX or something, right? That sounds cool, doesn't it? Like, doesn't that sound cooler than like managing data centers at Google? And the answer is not yes for everyone. I understand that, but like that's kind of where my head's at with it always. Is it's like writing software is cool. I love it. That's why I do it. But it'd be sick to to do some real impactful things that have a little bit more, have some more tangibility and reality. But I just didn't enjoy the study enough to pursue it. I'd love to know how UNSWIT stuff runs, especially when you go to download your academic transcript and it takes 10 seconds, presumably, to put it all together. Yeah, I wonder that too. I don't know why it takes 10 seconds. Pulling the data might be a second or two if the services aren't connected. Generating the PD, if they have to pull the data from another service, and then they have to generate the PDF, which could take a second or two, and then they want to store it somewhere. I mean, I'm surprised it takes 10. That's the kind of thing you'd expect to take 4 or 5 seconds. So, I'm sure it's a cascade of costly things. Anyone who has ELS things they'll get an email from me this week, probably tomorrow. What brought you back to lecture? I had no money. I was in the startup land with no money, because you don't make a lot of money in startup land when you're trying to deal with companies. So that was why I came back. So I was looking at my bank account and I was like, you don't have any money left. And I didn't want to quit the startup, because I had to quit the startup and go get a different job. But yeah, that was why. Obviously, I liked the work. I could have gone and got a job doing other things that pay more too. But I like the work. So it was like, I like this work and it pays, so I can pay my rent and stuff. Andre says, any thoughts on the old time question, software engineering versus comp sci? The difference is so negligible. But I don't know, like software engineering, it's another whole year. I don't think thesis changes people. I don't think thesis is a massive thing. The compulsory industrial training, I guess, is useful, but a lot of students find work anyway throughout their degree. Honestly, some of the software engineering courses are cool. I don't think I appreciated them when I was a student. I think I learned a lot of those things through industry work as opposed to at uni. So like there are courses now like COMP2531, DESN 2000, COMP3900, which are in comp sci. Actually, I don't know if DESN 2000 is. Maybe it's not. Anyway, there's like more courses now that teach you about software engineering than there were in the past, and that is a good thing. So I don't think there's a massive difference or anything like that. Yep. Yeah, the whole less elective things. I understand why some people don't like the fewer electives, though. I have taken of late a controversial opinion that I don't like the structure of a comp sci program, and I've made that clear to people because I think that it's way too flexible and therefore we can't teach anything. And like the examples I give people are that imagine if there are some great courses out there that probably should be core. And one of the most obvious examples I can think about is maybe database systems, or I'm sure there's one of a few that would be core. And if everyone did that course, every other course could be transformed because you can assume things. Like from an educational standpoint, as someone who's taught maybe like 5 courses in CSE in the last 3 years, it's like the fact that you can't assume what people know to be anything reasonable is really hard. Like it's fine in a first year course, sure. But it's like, take this course here. Some of you have done 1531. Some of you are doing it next term. Some of you are doing 15. Like, you can't leverage things very easily, which really sucks. And you actually feel it when you're teaching how much you have to really skim things down because people just don't know stuff. And take like 6080, another course I teach. We can't teach some stuff. We could teach some stuff about UI and design and stuff if we knew that students had done human-computer interaction. Or similarly, students in the human-computer interaction courses could spend more time learning about design and less time learning about how to code if it was assumed they'd done Comp 6080, right? But these two things, it's just like you can do either of them, neither of them, both of them in any order, and I think it adds double up and stuff like this. So I'm less in love with the flexibility thing than I was as a student. As a student, I was like, this is the best thing in the world. That's why I did it, because I have a poor attention span. But yeah, I think just as I've gotten through it more, I'm kind of just like, I actually would be, if there was a vote, I would definitely vote for like a more rigid, still some electives, but I mean like, most a relatively rigid degree, because I think at the end of the day, if no one knew better, that people would come out on average as better graduates. Um, because at uni, like you don't stud like you don't learn a course at uni and then you're set for life anyway. You know what I mean? Like they're all just tasters to get you ready for what's next, whether it's more study or industry. Like no one's ever like I've never seen someone be like, "Wow, you studied, you know, um, these particular three electives. We're gonna hire you because you're so skilled at these three things." It's like, sometimes you see things like I have lots of students in C++ email me and be like, oh, like when I say lots, I mean like 5 a year, like email me and are like, oh, because I did this course, I got a job with a company that uses C++. It's like electives are good because you need electives to allow for some things like that. So I'm not like anti-elective. It's more just like, I'm more just pro-structural nowadays. And maybe that stance will change, but yeah. Like, Git's a good example. In 1531, Git's compulsory, because you have to learn Git. And we use that in other courses now, which is amazing, because other students get a chance to actually, like, do more Git and practice Git and get really comfortable with it. Instead of, and they're good things. So that's easy, though, because first year and level 6 courses are so far apart, you can assume people know them. Like you can usually assume people have done 2521 when they do a level 6 course. So it's not totally screwed, but I think it would be cool if there were more structured programs. Chewy says, I had a suggestion about making 1511, 2521, 3121 into 4 courses in my experience so we could go over things like hash maps in more detail, and I feel like these are core classes in CompSci. So that's interesting. I definitely maybe feel that with 2521 and 3121. 1511, maybe. I mean, just because it's in C, I guess. But I definitely think there could be more kind of linking between 2521 and 3121 for sure. Because it lets you build on things, right? Like you want to build on things. That's how you get the most out of education per unit time. Anthony says, do you work with any programmers who are originally mech engineers or wildly different to CompSci, and how do they compare to the CompSci kids? There's a lot of electrical engineers in CompSci. There's some mechanical engineers in CompSci from what I see. Electrical engineers tend to be better computer science converts because, well, I think electrical engineering is hard. And I don't say that subjectively. I actually think it is harder than comp sci and mechanical engineering from what I've seen. And that's a very limited view, but from my time like running SunSwift for a few years, the thing that always astounded me was that it was incredible watching how quickly the electrical engineers could pick up on anything software and mechanical, and how much the software engineers could pick up on a lot of things mechanical, and how much the mechanical engineers struggled to pick up on the other two things. I'm not saying that that's as simple as it is, because it's not. I think a lot of it is that as you get more abstract, things are harder to understand. I think that's why a lot of software engineers really struggle with electronics, because even though we're like quite abstract thinkers, electrical is like another whole step into the realm of, electromagnetism and just analog circuits, and it can get pretty crazy pretty quickly. Anyway, that don't read into that too much. That's just more a fun random thing I used to notice. Though some of the smartest people I know are mechanical engineers. Some of the most terrifyingly smart people I know are mechanical engineers, actually. A few UNSW grads doing very well in Formula One from that background. But generally, the hardest thing is for elec and mechanical people, I think, to transition into, like people who didn't do comp sci, is for them to transition into roles that have really heavy architectural needs. Because like as a software engineer, the thing that separates you a lot of the time from just generic programmers is the fact that you've had to write more software and think more about structures and think more about approaches and think more about design. Because smart people can learn how to program. It's harder to teach people all those little things about, how to structure a project, work in a team, time complexities, just all these little things that you pick up over 4 years that separate you out. So how do they compare if they didn't do comp sci? They can program. It's just often that they don't have like the knack for like higher quality programming approach or like working in teams. They pick it up eventually, but it's just slower because they're trying to catch up on what you've implicitly learned over years of a degree. But they're all I find most engineers are relatively smart. They can pick up most things pretty quickly. And naturally, I personally find mechanical and electrical harder than comp sci. That's why I dropped it, because I was lazy and didn't want to learn about mechanics. Am I planning on taking 2521 in the future? I don't know. Like, it's hard to explain to you all, but it's you'd be surprised how short planned as a casual my life is in terms of right now is when the conversations start about what I might teach in T1. So like T2 is not a topic that will come to the table for me and the staff until Christmas-ish. So I don't know. Maybe. It's hard to say. Like, I don't know. It usually depends on other staff. Like, I think an important thing to get to wrap head around is that I think generally CSE don't want casuals teaching things. So in a perfect world, they take me off everything because, well, not, you know what I mean? They take a lot off me because they prefer to have full-timers doing it, and for good reason. It's good business decisioning. Though at the same time, they don't always have like full-timers to do everything, so they need casuals to do something. And generally, if they have new full-timers, they try and push them more towards courses that they feel need some overhauling or extra attention. So if you were to look at my time at CSE over a longer period, if they found a full-time person to do 2521, they just get them to do it. And if they don't, they'd be like, well, Hayden didn't break it. Let's see if he can teach it again. That's kind of the flow of things. Yeah, I don't know. I'm probably going to be teaching 6080 for a while. That'll probably be the last course I end up having to move away from if work gets even busier. So anyway, any other questions? Andre says, thanks to 2521. Thank you to all the students in this course. And also, is leak code good for coding randomly during the holidays? Yeah. I mean, leak code just helps you think about coding algorithmic problems. You've got two ends of the spectrum, right? Go answer hard leak code questions and go build yourself a website. And then there's lots of things in between. And, the leak code questions are going to test your thinking as a problem solver, as a mathematician, as a computer scientist, as a 2521 student. And on the other end, you've got yourself, building a full stack, Android app would be too, website's just a term. It's like building yourself a full stack application, which is going to be hard for all the other reasons. It's going to be hard reading through the documentation, setting up the environment, making all the different things work, dealing with versions, blah, blah, blah. And that's where the difficulty of that stuff lies. So they're both really useful skills. It's just a question of what you want to spend more time on right now. And Yeah, so it depends what you want, you know. LeetCode's great for really focused, narrow stuff about problem solving, and go deal with a full stack. I mean, you can go make yourself like I mean, you know, Flutter's a really popular tool now, right? Go teach yourself Flutter. That's probably a worthwhile investment. Who made Flutter? Google. Okay. Flutter's like a new toolkit that lets you basically build like apps. I haven't used this, just to be clear, but like it lets you build apps for like it lets you write code once and build this app in Android and iOS and everything. And it's just like it's just like a language that Google wrote. That's I don't know. I don't know what you'd call it closest to. It looks like some weird mix of Java and JavaScript, or you know, some kind of Java C sharp. Anyway, this would be fun to learn. I would go do that because if you can build mobile apps, you're extremely employable, irrespective of everything else to do with your degree. And I think this stuff is still picking up usage. Like it's probably going to continue to get more popular for the next 2 or 3 years, I would guess. But I don't know. There's lots of fun little things to learn like that are off the thing. Thank you for the kind words, everyone, too. And I probably can't talk much more today, sadly, about other things because I have to get back to other things. But I have not done any Flutter, no. Because I come from a React background, so I do a lot of React Native. And React Native is a similar thing. It's just in JavaScript instead of some other language. Is Flutter written in Dart? Is that how it works? I think Flutter's written in the Dart language. Maybe I'm crazy. Maybe I've got those. Oh, it's written in a few things. React Native is, from what I can tell from my very, very limited reading, React Native is usually less preferred than Flutter for building mobile apps. However, if you're also building a website with JavaScript, React Native is usually good because you can unify code bases a bit. So if you built a website and then wanted to make it mobile, I'd probably look at React Native. If you wanted to start a project and you wanted to just build a mobile app where you should start, then I'd probably look at Flutter. But I've only spent 20 minutes Googling that, so I might be missing a lot of things. Google things, don't listen to me. Anyway, thanks everyone. I'll wrap it up there, and good luck for your exam on Thursday. Me and Kevin will be keeping an eye on things and send out emails and everything else. So, yeah, have a great day, and enjoy the warm weather, and stay safe from COVID. Cool. See ya.